In the last lecture, we went through the introductory concepts for solid principles. In this video, we will study single responsibility principle. Single responsibility principle's definition is very simple and is inherent from the definition itself. A class should have only one responsibility. And what's a responsibility? Well, it is defined as a reason to change. And yeah, that's it. That's your single responsibility principle. Simple, isn't it? Well, not at all. Single responsibility is the most powerful principle, and it's very important that you understand it very well. And to do so, you would need to understand what are the reasons for which a class can change, or how to find the number of reasons there are in a class due to which it can change. So let's have a look at what a change is. A change can be defined as an alteration in behavior, and if we are talking with respect to class, the methods of the class represents its behavior. Now this does not in any way mean that the number of methods in a class is equal to the number of reasons a class might have to change. Now that you know what a change is, there could be a big change, where you add a lot of code for your wonderful feature, or it could be a small change or a breaking change. And trust me, a breaking change is capable of getting you fired in the worst case. So let's move on to an example to understand this better. Let's say you have this awesome web calculation engine which can take two numbers from you and perform some operation like add, subtract, multiply or divide. Let's say this was the version 1 for your application, and now you want to add new features for this awesome app. Let me ask you something. Can you be 100% sure that your change for the new feature is not going to break the older features? If yes, then congrats. If no, then keep watching. I have attached some sample code for the addition feature for this app. Can you identify how many reasons does this class has to change? You can pause the video and try to figure that out. Okay, I'm sorry if this was the first time someone asked you to look at the code and identify the reasons for it to change. If you have found a few, then that's great. If not, let's do a deep dive. So, according to me, if you add new features to this app, following are the reasons due to which this class would need changes for. If you make any change to the add method, or if you need to change the subtract method, or let's say you want to add a completely new category of numbers which is complex number, and you want to support addition for complex numbers as well. So in that case also this class will require changes, because if you see the addition method which is implemented in this class, it has a lot of responsibilities. It has a lot to take care of. It has to take care of integer numbers, it has to take care of decimal numbers, it has to take care of big integers, and if you try to add new features to this method such as complex numbers, you risk breaking the existing functionalities which the method was already doing. Okay, now if you add any more methods, let's say multiply or divide or something like that, that still requires your calculator class to change, because you will be modifying this class. And trust me, whenever there is a need for modification, there is a risk involved. Well, now you see why this class is not following the single responsibility principle, because this class has 5 reasons to change, maybe more if you add multiply and division features. Let's see what we can do to make this class SRP compliant. And here we have given only one responsibility to the calculator, and it's the responsibility of delegation. The calculator acts as an interface for its clients where they can supply their input and the operation they want to execute. If you look closely, calculator is not doing any number validation, type checking, or even performing any addition or subtraction. You might argue that this is same as the previous one, but this is not the case. In the previous example, this class had a lot of reason to change as mentioned in the previous slide, whereas in this case it has only one reason, which is handling delegation for a class of expression. Even if you add an additional method for ternary expression, the responsibility of the class remains same, as this won't increase the number of reasons for the class to change. Okay, let's again have a look at the previous code. Do you really think that it's the calculator's responsibility to perform the actual addition? I mean, on a higher level it is, but if you dive deep, your calculator doesn't add the numbers. It just takes your input and has a way to display the results. It is just an interface. The actual addition happens inside the IC or the chip, which means it's not the calculator's responsibility to add numbers, and clearly in our code we are violating it by giving it too many responsibilities than it can handle. And that is why I took out those additional responsibilities from that class and gave it something which it can handle and what it should be supposed to use for, which is delegation of the input and the operation. Well, let's have a look at how can we decide if my class is SRP compliant or not. And this depends on a couple of things. Let's say if you are really looking at classes which are really big, like more than 1000 lines, or let's say 600 lines, or you're looking at some really large methods, like methods having more than 50 plus or 60 plus lines, then these are clear indication that these methods or classes are not following the single responsibility principle. You can also look for methods which have too many parameters. Now, how many is too many? So ideally, if you're constantly seeing methods which have more than 4 or 5 parameters, then those many arguments fall into the too many category. Also, try writing a unit test for the class or method you are testing, or you are trying to see if that's a SRP compliant class or a method or not. If you are finding it very difficult to write a unit test for that method, then it's a very good indication that this class or a method is not following the single responsibility principle. Now, what can you do to make it compliant? Well, the most simple thing that you can do to make your class SRP compliant is that if you can name it in a better way. Other than that, it really depends on your ability to group similar kind of behavior together, and this will require some practice, but if you keep looking for it, you will get better at it. Along with that, if you can solve the other 3 problems which I mentioned before, like really large classes, really large methods, try refactoring those classes to smaller classes, try refactoring those methods to smaller methods, try reducing the number of parameters to a method, and try writing a unit test for it. The process of writing the unit test itself will make you refactor the code such that it becomes more compliant to the single responsibility principle. Also, assuming that you are following good naming practices where your method name reflects what the method does. If your classes or method names have really large names like bake and serve and collect bill, that's a clear indication that you are doing more than one thing. If your methods or class names include some conjunctions which are connecting 2 different actions or maybe 3 different actions, then that's a very clear indication that you're violating the SRP principle there. Now, one most important point is that do not confuse more responsibilities with a method or a class having multiple dependencies which they are calling to get the job done. For example, have a look at this code. This method doesn't have 3 reasons to change. You may argue that there's 3, but that's not correct. Think about it this way. What is the responsibility for my responsible class in this example? It acts as a backbone for other dependencies to execute, a unit of work. Its responsibility is to orchestrate. It is like the nervous system for the program. But again, don't add too many orchestrations such that it becomes like a God class. That's again a coding spell. So keep your class size in check such that it doesn't become a God class doing everything. So let's have a look at common responsibilities for a class. A class can be an action taker or a delegator or an orchestrator. If you look at the slide in our previous example, the class myResponsible is an orchestrator as its responsibility is to orchestrate. Whereas dependency 1, 2 and 3 are more often action takers. A delegator is a class which acts as a proxy to another class, and you can watch my video on the proxy design pattern to learn more about it. Link in the description. The responsibility of a class doesn't depend on the number of methods in the class, as I have said before. If you observe closely, I have just changed the name of the class and the number of responsibility reduces to 1. In the initial example, the class is named as file uploader, and what this name reflects is that this class will have a responsibility to upload something. Now, when I add a download file method to this class, the actions of this class and the name of this class do not match with each other. The action clearly says that this class is doing 2 things, whereas the name suggests that it's only responsible for the uploading part. But see, I have just changed the name from file uploader to file network IO gateway. Now, this is a more interesting name for the class as it describes more about what the class is responsible for. And just by changing the name, we are able to group these 2 methods under one responsibility. So now let's have a look at what should you do if you are creating a new class or refactoring an older one. Try to think of good names for your class which can represent what the methods in your class are doing collectively. Try to put the cohesive methods closer to each other. And try avoiding long and descriptive names which contain conjunctions like and. Try to avoid a butterfly effect between your methods, as you saw in the example where the subtract method was calling the addition method, and any bugs which are there in the addition method will also break the subtract functionality. So this is what it's called butterfly effect. You make a change somewhere and some other feature breaks. You can also list down all the methods in the class along with the class name and see if it makes sense for all the methods to be there. Once you find that a class have more than one reason to change, extract those additional reasons out in a separate class. Well, SRP is not only applicable on classes and methods, you can also apply it on a package level or over a module level itself. Always remember, responsibilities can be big or small, but it should be one. Okay, so now let's have a look at some advantages of single responsibility principle. If your code is following single responsibility, your code will be less fragile. You can test it easily. Your dependency will be very loosely coupled and it will be very easy to debug your code. The most important advantage, which is my favorite as well, is that you will be able to implement a pluggable architecture, because SRP really allows you to build your code like a plugin based model where your code is so much clean that you can just swap out any dependency and everything works as expected. If you're really able to master the single responsibility principle, your code will start looking like a jigsaw puzzle, and that's a very good thing. Imagine each piece having one and only one responsibility. That's how your classes should be: crisp and clean, doing one thing with extreme excellence. How to keep single responsibility in check? Start learning design patterns. It really allows you to restructure your code in a very clean way. Also learn refactoring principles. It will also allow you to keep your coding quality in check on an overall basis. You can also go for test-driven development, because writing unit tests for your code actually helps you to basically remove additional responsibilities out of the class. And it's very easy to test a class which only has one responsibility. At last, you can also read code written by other people, and you will get a fair enough idea how the single responsibility principle works. That's my take on helping you understand single responsibility principle. If you have any doubts, let me know in the comments. Otherwise, till we meet for the next time, goodbye.